What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button, and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
It's not that simple to understand that even such a trivial thing as brake pads are not so simple. It is enough to remember what pads do and under what conditions they work. At a basic level, everyone remembers that the pads press against the brake disc and thus slow it down. But we need to dig a little deeper. Firstly, the pads work in extremely high temperatures. During intensive work, the brakes heat up to several hundred degrees Celsius. In this case, the pads need to maintain a stable coefficient of friction with the disc in a wide temperature range, not to crack, not to burn, not to crumble, and, you see, not to squeak. Friction coefficient is a dimensionless value characterizing braking efficiency. The higher it is, the shorter the braking distance of the car. However, as a rule, the coefficient of friction decreases as the temperature rises. At the same time, the braking efficiency decreases. In the course of their work, brake pads not only have to deal with water and dirt, but also with road chemicals. In addition, they need to isolate the brake mechanism from heating from the side of discs. Brake fluid, of course, is designed not to boil at temperatures up to 230 to 250 degrees, but discs can be heated to higher marks. In this case, the pad should provide the optimal coefficient of friction, but at the same time not to be too abrasive, so as not to excessively wear the brake disc. All in all, the operating conditions are nightmarish, even mutually exclusive. However, many pads can cope with them. First of all, it is a design that has been developed over the years. Again, let's start at a basic level. Everyone remembers that a pad is an overlay of a braidable material on a metal plate. The pad is officially referred to as the friction layer. It is the layer that has to do most of the work we listed above. The metal plate is self-explanatory. It's a steel base that is attached to the brake mechanism. Between the base and the friction layer there is another important element, the adhesive layer that binds them together. For many people, this is the end of the pad structure, and what else can be added here? In fact, there is a lot more. The next important layer is a thermal insulating layer. It is applied to the steel base and is designed to further insulate the brake mechanism and fluid from heat, in addition to performing a damping role, reducing the level of vibration and, consequently, the risk of squeaking when braking. Another one is noise isolating. It is either a lining or a special high-temperature mastic on the backside of the pad. Well, and the finishing layers, anti-corrosion and lapping. The first covers the entire pad, except for the working surface, and the second, on the contrary, is part of the surface structure of the working surface of the friction material. However, while the thermal insulation layer is mandatory for major manufacturers of quality pads, the other layers are optional. Their presence may depend on the technological level of the manufacturer or the price category of the pad. So, we have found out that the largest and most complex set of tasks is that of the friction layer. What does it consist of? There is no single and exhaustive answer to this question. Firstly, because its composition varies from manufacturer to manufacturer. And secondly, even one manufacturer has a great number of variations in the composition of friction material for different tasks, product lines and end users. Nevertheless, it is possible to identify the main substances that allow the friction layer to fulfill its tasks. These are bonding fibers that provide strength, elastomers that reduce brittleness, abrasives that increase the coefficient of friction, lubricants that allow the pad to slide on the disc and reduce unwanted vibrations, and fillers and bonding adhesives that ensure a homogeneous structure and a strong bond between the components. If we talk about the composition from the actual point of view, we can note such components as graphite, steel wool, aluminum oxide, Kevlar shavings, nitrile rubber, and so on. Separately, we can mention that during production Ferodo pads of Premier series undergo the procedure of friction material surface burning at high temperature, which allows to remove resins and organic inclusions from a surface, exposing abrasive grains. This allows to provide high efficiency from the first braking. In the production of disc brake pads for trucks, a lapping layer is applied to the working surface of the friction material. It is actually AN in addition to the composition. The friction layer can benefit from design features. The simplest option is a groove on the working surface of the friction material. This groove mainly serves to reduce the internal tension of the material when heated, allows the removal of wear products from the working area and can also be used in the design of the pad to reduce the likelihood of scratch during braking. A second design feature of some pads is the chamfering of one or both sides of the friction lining. This technique helps to facilitate the development of the disc and pad, as well as to reduce the vibration background that causes noise and squeaking during brake operation. Does all of the above help pads to perform their tasks absolutely perfectly? In ideal conditions, yes, if the pad is manufactured according to the rules and the operating conditions remain within the design limits. In real life, however, not everything always goes as planned, and the pads are even tighter. For example, a long descent on a mountain serpentine on a hot summer day is a pleasant emotion for the driver and a personal hell for the brakes. Slushy winter, when on roads day after day accumulates a mixture of water, mud, reagents, fuel, and lubricants and other good, it is a hard time not only for a body, but also for brakes. Well and banal wear and tear cannot be written off either, even if we do not talk about the conditions when a careless rider rolls the pad to the metal. Excessively worn pad works less effectively. Let's take a closer look at why pad quality comes to the forefront in challenging conditions. What's wrong with cheap pads? In general, the answer to the question, what's wrong with cheap, low-quality pads is simple. Literally everything. You can take the list of tasks and problems above and add a minus to each of them. Actually, this is what we are going to do now. First of all, cheap pads are an inefficient composition of the friction layer compound. It is not even possible to talk about ecology in this case. Economy and ecology are almost always mutually exclusive paragraphs. Actually, up to some time nobody thought about ecology. At the dawn of its development, in the beginning of the 20th century, pads were made on the basis of asbestos fibers and phenol formaldehyde resins. However, by the end of the last century, the carcinogenicity of asbestos had become a well-known problem, so its impending ban became clear to everyone. Leaders of branch began to develop alternative compositions. So, Ferodo already in the beginning of 80th years has let out the first. In Europe, brake pads, not containing asbestos. In the current century, the ban on its use was introduced by almost all major countries, so that modern pads, if we do not take into account the outright counterfeit, do not have it in the composition. We have already talked about the composition of the friction material above, but we can add one more thing. In terms of composition, most modern pads can be divided into pads with low steel content, semi-metallic, and organic. Actually, the categories require a minimum of explanatory comments. In pads with low steel content, as is clear from the name, the friction mixture contains a small amount of steel fibers, including the use of corrosion inhibitors and abrasives. In semi-metallic pads, metals, specifically steel fibers, and amp, GT, 50%, and graphite, make up a significant portion of the friction compound, without the use of specific abrasive inclusions. Organic pads do not use steel fibers and abrasive particles are present in a finely dispersed form. Following the increasingly stringent environmental regulations, modern friction materials are produced with low or zero copper content. Ferodo specialists were among the first to develop and implement the technology of production of friction materials with such copper content, called ECO friction. All pads Ferodo Premier Series are produced by this innovative technology. There is another group of highly specialized friction materials designed for high-performance braking systems, designed to work in extreme conditions. Among other things, they use a higher content of ceramic inclusions. The threshold operating temperature in such braking systems may be, if we go back to cheap pads, everything becomes obvious in terms of their performance. Poor adhesion of the friction layer to the brake disc is only the tip of the iceberg. First of all, it can also be inhomogeneous depending on the temperature. Already low efficiency pads can work even worse when heated. At very high heating, the situation can be aggravated by the gas cushion effect from vaporizing resins at high temperature. In this case, braking efficiency drops to almost zero. Poor wear resistance is the next disadvantage of cheap pads. Modern car owners are somewhat spoiled people, and they demand from pads not only silence, but also cleanliness of discs. If the pads are very dusty, they are scolded. Say, you cannot go to the car wash, and black dust firmly adheres to the wheel discs. Besides, the dust from the pads is not only an aesthetic problem, because it contaminates the brakes. So, add to this the fact that dusty pads are, as a rule, quickly wearing pads, and the picture of unsuccessful economy will be formed by itself. In the context of the loss of efficiency of the pads in operation, we can remember a very unacceptable phenomenon for the pads, the tendency to overheat. If cheap pads are burning, you're screwed. Overheating is the destruction of the structure of the friction layer and the pad as a whole, a drop in braking efficiency at times, and in addition, the possible boiling of brake fluid, especially if it has not been changed for a long time, and it contains a high content of moisture. The next element of cheap pads is increased aggressiveness to brake discs. One of the ways to increase the friction coefficient of the pad without spending a lot of money is to increase the abrasive content. For manufacturers of cheap pads is not so important that the scale shifts to the other side, and the pads begin to actively wear the discs. Well, in case of active operation, all this is fraught with overheating of discs and calipers, as well as the subsequent deformation of discs. Overheated discs cause runout when braking, and the next step, their replacement or, to a lesser degree of probability, grinding. There is nothing to say about the fact that pads of increased abrasiveness are also prone to noise during braking, against the general background. These are just trifles of life. Conclusion: in general, today we have not made almost no amazing discoveries for anyone, but just repeated simple truths and supported them with theory. Therefore, the conclusion from the above will be simple. In fact, you cannot save much on cheap pads. At best, the economy will turn out to be a low resource and, accordingly, more frequent replacement of pads, and this is already an additional expense. In a more unsuccessful variant, it is possible to kill discs and to face even more expensive maintenance of brakes. Well, and in the most negative scenario, you can kill not only something. In general, you should not save money on brakes, it is not worth it. But what is worth it is to take the time to choose quality pads, for example, from the brand Ferodo. The manufacturer of these products for more than 100 years has accumulated tremendous experience in the field of creation and production of parts of the brake system. In conclusion, while Ferodo pads may offer a budget-friendly option, it's essential to weigh the potential trade-offs in service quality and braking performance. As we've explored, the choice between cost and reliability can significantly impact your driving experience. Ultimately, it's crucial to consider your specific needs and driving habits before making a decision. Investing in the right brake pads can enhance safety and performance, ensuring you stay in control on the road. Thank you for watching, and drive safely.